So for number 3, they want you to check if cosine of 0 equals 0, and it's not, because cosine of 0 equals 1, so this is no. For number 6 and 9, we are verifying the values of x to show that they make the equation true. So for number 6a, x is pi over 3, so secant of pi over 3 is 2, and 2 minus 2 is 0, so that checks out. 5 pi over 3, secant of 5 pi over 3 is also 2, so 2 minus 2 is 0, so that checks out. For number 9, same thing, except the equation is a little longer. So notice I replace all the x's with pi over 2, and so sine of pi over 2 is 1, 1 squared is 1, 1 times 2 is 2, minus 1, so that gives me 0. 7 pi over 6, the sine of 7 pi over 6 is negative 1/2, and so it's 2 times negative 1/2 squared, so remember only the negative 1/2 gets squared, so I get 2 times 1/4, and then a minus a negative is a positive, and so this is 1/2 plus 1/2 minus 1, right here, gives you 0. For number 12, they want you to find all values of x between 0 and 180 degrees. That make that equation true, and 0 and 360. That make the equation true, and the only value is 180 degrees. Alright, for 15, you are solving for x again, values that make the tangent ratio equal to 1, and so that would be 45 degrees in quadrant 1 and 225 in quadrant 2. So this is straight from the unit circle. So is number 18. What values of x make this equation true? If x was 7 pi over 6 in quadrant 3, and also in quadrant 4, 11 pi over 6. 21, tangent negative would be in quadrant 2 and in quadrant 4. Okay, and for secant, square root of 2, that's the same as cosine radical 2 over 2, the reciprocal. That would be in quadrant 1 and in quadrant 4. Okay, for 27, tangent x is negative 1 this time. That would be, and now we're talking about radians, right? Different from 15, that was in degrees. So that would be quadrant 2 and quadrant 4. Number 30, a little bit of work. We're isolating the sine x, so we subtract the 1 over to this side, and then divide by radical 2. Rationalize the denominator here, so you get this as your ratio. Because it didn't tell you from 0 to 2 pi or 0 to 360, you have to give it in general form. So you take one of the values of x, 5 pi over 4, and you add 2 pi n, because every time it comes back to 5, to the same angle, 5 pi over 4. Let me just sketch it right here real quick. So that's going to be right here. Every time it comes again, that would be another solution. So we're adding 2 pi every time, or subtracting 2 pi if we're going in the negative direction. Okay, so the same thing happens with 7 pi over 4. Okay, we add 2 pi n because we want to give all possible solutions. For number 33, let's move it a little bit over. You add 4, divide by 3, and then take the square root. By taking the square root, you put plus or minus in front of the number on the right, and square root of 4 is 2, square root of 3 is square root of 3. Rationalize it and you get plus or minus 2 radical 3 over 3. Okay, so that's a pi over 6 angle for x. But because it's plus or minus, it's going to be this one and this one for, and then this one, oops, and this one. So there's actually 4 answers. Okay, but notice how I only have 2 right here. Because pi over 6, instead of adding 2 pi, if I add pi, I would land right here. So that would take care of that root of that answer. Okay, and then same thing for 5 pi over 6. I'm going to do 5 pi over 6, and instead of adding 2 pi, I'm going to add pi, and that would take me here. I add another pi, and that would take me back over here. Add another pi, so by writing the answer plus pi n, I don't have to write the other 2. I don't have to write this one separate, and I don't have to write this one separate. Okay, so here's the solution, the general solution to this equation.